In this lesson, we're going to learn to label amino acids as polar and nonpolar and as acidic, basic, or neutral. And this will be important when we start to look at the structure of proteins and enzymes. First, we're going to classify neutral amino acids. There are 9 amino acids which are considered nonpolar, neutral, so we just call those nonpolar. And these contain aliphatic, which just means a hydrocarbon chain, so a chain of carbons and hydrogens, or aromatic rings. And remember, our aromatic rings are 6-membered rings with alternating double bonds. For polar neutral, there are 6 of those total out of the 20, and they contain a hydroxyl group, so an OH, a sulfur, or an amide. You might need to review your functional groups to make sure you distinguish between an amide and an amine. They're 2 different things. So if we look at our 2 examples below, we see we have an aliphatic chain or a hydrocarbon chain because this is our backbone that I've circled in red, and in blue I'll circle the side chain because remember, everybody must be in one or the other. An atom can't be in neither, nor can it be in both. So when I look at my side chain, I see that I have a chain of carbons and hydrogens, and so this will be a non-polar amino acid. When I look at the one on the right, again, I'm going to mark my backbone, and then I'm going to mark my side chain. And I see that in my side chain, I have an amide group because I have a C double bond O attached to the NH2, and that's going to give me a polar neutral. Notice that I only look at the side chains when I'm classifying my amino acids. The backbone on every single amino acid is the same, so I can't use that as a way to classify them into categories. Now let's look at what happens when we have acidic or basic amino acids. Because they're acidic or basic, they're also polar acidic or polar basic. So while we can shorten nonpolar to just that, if we say something is polar, we need to specify polar neutral, polar acidic, or polar basic. So polar acidic contains a carboxylic acid or the carboxylate ion in the side chain. So if I look here at the one on the left here on the bottom, I have my backbone, my NCC, so my amine group, my CH group, and my C double bond O OH. And then I have my side chain, and I see that this has a carboxylic acid in the side chain. So this will be polar acidic. And this is also called negative. So if it's asking for a negative amino acid, you're really looking for polar acidic. So those 2 terms are somewhat used interchangeably. For the next one, polar basic, there are 3 of those. And these contain an amine group, which may be neutral or charged, in the side chain. And these are also known as positive. So if it's ever asking for a positive amino acid, what they mean is basic. So I'm going to circle my backbone, which means this is my side chain. And what I see in here is that I have an amine group, at least one amine group. In fact, I have 2 in my side chain. So this is going to be polar basic. As with many things in chemistry, there are exceptions. And these are the 2 exceptions you need to worry about. The first of which is tyrosine. Although it has the aromatic ring, it also has an OH group, and so we treat this as polar neutral. The other exception is methionine. This is nonpolar. Although it contains a sulfur, which may make it you think it's polar neutral, because of the positioning of the sulfur in the chain and its electronegativity value being the same as carbon, it actually makes this one nonpolar. So you do need to know these 2 exceptions. I would encourage you to use the rules that we've applied because these are consistent with sampling and with any textbook problems in the exam. With anything where there are exceptions, there are always gray areas, and so it could be possible that other lists may reference these slightly differently. Let's look at a few examples. Classify serine as nonpolar, polar neutral, polar acidic, or polar basic. Our first step is to identify our backbone, in which case we're looking for our amine group, our CH, and our OH, our C double bond OOH group. So that's our backbone, which means that our side chain is here. And what we see in our side chain is this OH group. And so that tells us that we're dealing with something polar, but it's polar neutral because it's not acidic or basic. So that is polar neutral because it has that hydroxyl group in the side chain. Again, never look at the backbone to determine the classification of an amino acid. Classify phenylalanine. Let's find our backbone, our amine group, CH, C double bond OOH, and then find our side chain. Here we have an aromatic group, no other atoms in there, and so this is a lot of carbons and hydrogens. And so just like when we look back at intermolecular forces and polarity earlier on with our molecules, having a bunch of carbons and hydrogens gives you a nonpolar group, and so this is a nonpolar amino acid. The polar components that are in this backbone do not count. Classify proline. So this one is a little bit trickier just because of the way it lays out and the way that proline connects to the molecule. So when I look for my backbone, okay, the carboxylic acid part is easy. That's over here. And then I have my C here. That's part of my backbone as well. And this amine group is actually part of the backbone. Okay. So the group of proline actually is just this chain of 3 carbon groups and the corresponding hydrogens. It's tempting to think that this NH2 is part of the side chain because of the way it's drawn, but proline is a little bit odd because it connects to the backbone in 2 places, and it's in fact the only one that does that. But when I look at what's in the side chain, what I see is I have a bunch of hydrogens and carbons. Therefore, this is going to be a nonpolar amino acid.